So what is Python and where do you start? Watch this and I'll break it down for you. Hey, welcome back y'all. So I'm really excited to give you this first Python video from my channel. And I don't want to jump straight into coding. What I really want to do is talk about what Python is, its use cases, and also different libraries, and talk about what other companies also use Python. And then we'll follow it up with a lot of videos of what Python can do for you. So without further ado, let's get started. So I know oftentimes when people hear a programming language, they're like, hey, I'm not a data scientist, I'm not a data engineer, so I don't know what it means, and this isn't for me. Well, what I can say is that this channel, Nexion Analytics, is going to provide you a way to really pick up Python in the most beginner-friendly format so that anybody can watch a video on Python and really learn how to use it within their organization. Now, Python is simple, it's flexible, it's fast. Companies like NASA to Netflix use it every single day, and they use it to automate data, analyze it, and to power their AI data models as well. But by the end of this, you'll see how Python and its libraries can help you achieve actionable intelligence within your organization. So what is Python really? Python is a high-level programming language. Out of the box, it comes with 70 different functions ready to go, such as print, len, sum, and so much more. So these handle things like basic math, text, and loops. And with it, you can analyze data, you can create calculations, you can visualize it as well to a certain degree. But the benefit of Python is that it's readable. So you can really look at it and determine what it's doing for you just by glancing at it, even if you have no knowledge about what Python is or does. So Python also powers video games. It also powers the ability for you to connect to things on the web applications or on the database, and how things kind of flow within the data ecosystem as well. But why is Python important? It's flexible, it's fast, it's easy to use. There's a lot of companies that use it, such as Google, Netflix, NASA, JP Morgan, and so many others. And it's supported by so many out there. It's a large community, so you can almost go anywhere and see public forums to where they're going to help and support you with Python, or they've already done what you're doing before, and you can kind of look at what they've built thus far. But for an organization, what it means is less manual work, which is really what we want at the end of the day, right? We want efficiency so that we can have more free time to do what we love to do, right? So buying ourselves time back. So that all comes in the name of efficiency so that we can optimize what we're doing within our workforce. So think about the times that you've been building an Excel spreadsheet or maintaining it, and you have to build that product maybe over and over every time you get a new job or you switch to a different section or company or etc. What if I told you that you can do all that in Python and you don't have to do it ever again because Python will just automate the entire product in full? All right, so let's talk libraries now. So Python natively has 70 plus built-in functions to it, but it can't do everything alone, meaning you have different add-ins or DLCs, I like to call them, that then complement Python so that you can do multiple different things, such as build charts or create tables, do statistical analysis, things like that, right? So Python only has 70 different functions in it, and those 70 different functions are not supporting everything that you may want to do within your workforce. So then you have libraries, and there's hundreds of thousands of different libraries that you can pipe onto Python and create charts, you can create tables like I was talking about, but no single one can do all of them. There's no one library to kind of rule them all. So think of libraries as like a role for a team member. So each team member brings something new to the team, and they can deploy that within their organization and then have a different avenue of delivery within your workforce. So before I dive into what the libraries truly look like, I'm just only going to name a few and not all of them because there's so many, right? But I'll highlight the major ones that are commercially utilized right now. But I don't want you to get too freaked out simply because there's a lot of code that I'm going to show you. They are basic, however, they may be alien to you, and that's okay. But we're going to talk about them going forward in the future and how these libraries can support you and support your workforce over time. But just to recap so far, Python is a programming language. It has 70 different functions natively built into it, but it cannot do everything on its own. Natively, it cannot talk to a database. It cannot talk to the web applications out there. It can't talk to so many other things, and that's where these libraries come in. That's where these add-ons or these DLCs, I like to call it, come in, because they have their own use case and they augment Python to help it be fully functional in the regards that you're looking for. All right, so first up we have Pandas. So Pandas is basically like Excel on steroids. It's going to allow you process things in a tabular format, so a table format, as you can see in the bottom right here. And then it allows you to process those things so fast, way faster than Excel. And Excel has a limitation too, as we know, right? It can only go up to about 1 million rows, just past that. And Pandas can optimize that efficiency for you so that you can go way past 1 million and then run any tabular data that you want. So Pandas has about 250 different functions within it. Some of the major ones are going to be group by and merge. So Pandas allows you to bring data together. You may be curating your source of truth so that you can create something for a front-facing application ready to use, and it may be calling that table, and you're joining tables together and doing all these things, but also allows you to clean, filter, and analyze the data as well. Way faster than Excel, because Excel has a cap, right? We know it goes only past 1 million rows, and Pandas can do that at the drop of a dime at any time. So there's a lot of interconnectivity between these libraries too. So a few have not mentioned are Matplotlib, which allows you to build charts, and I'll mention that here in a second too. But Pandas can work directly with it as well, so that not only are you just natively writing in Python, you're piping in this library of Pandas, but you're piping in other libraries too. Now you have a complete arsenal of code that you can write so that you can visualize and propagate whatever you need on whatever end product that you may be developing. So with that said, let's go through this code real quick just so I can show you what Pandas can really do for you. So here, simply on line 1, what we're doing is importing Pandas. So it's importing that library, and we're bringing in alias. So alias is going to be the as, and we're saying, okay, instead of writing Pandas as a whole, we're just going to write PD, and we're going to reference it every time as PD. And then data is going to be your variable. So anything before your equal sign is going to be essentially your variable. And then within data is going to be your curly bracket. So month is going to be your column header. And then within the months, you have 2 months listed, which are January and February. And then within sales, you have the next column header, which is going to be your values. So you have 200 and 220. So as we know, going left to right, we know January's value is 200, and then February's value is 220. And then below that, we have data frame. So data frame is within Pandas, so it allows you to create things in tabular format, so tables, so similar to Excel. And then pandas.dataframe. So that's specifically telling you, hey, I want to display it in a data frame format. You have data, so it's calling this exact line now put it in an index. So give me rows starting at number 1 and then 2. And we only have 2 rows anyways, so it all lines up perfectly. And now we're saying print df. We're saying print this variable, and we know the data is being called into this line. So now we're just displaying everything that we want to display, and here's your output. So we have row 1, row 2 of January, February, the total amount of sales, and then the column headers up top. All right, so NumPy is next, and what it's used for is high-speed calculations and then big data. It has about 100 different functions to it. It has functions such as mean and dot. So dot is going to be dot product, and it's used in linear algebra and 3D graphics. And it's like Excel. Once again, it can do a lot of calculations super fast. So for Tesla specifically, it helps for the autonomous driving capability. And then for Netflix specifically, it runs the recommended search engine. And then with that said, you can only imagine how much it really does for NASA on a daily basis. But let's talk through this code real quick. So once again, we're simply importing NumPy and calling it NP. We're building our variable called ARR, short for array. And then we're saying numpy.array. So our array is going to be this entire bracket here, 1 to 4. And we're saying print the string of array based on this variable, ARR. So it's saying, okay, print array with 1 to 4. And then print the mean, and the mean is going to be based upon the array variable that we made on line 3. So our output is going to be array 1 to 4, and then mean is going to be 2.5. Now just imagine what Tesla does on a daily basis and NASA and think about the endless opportunity and possibility there really is there. All right, so next up is Matplotlib. So this one turns data into visuals. So one of my favorites, just me being a data analyst alone, I love to turn numbers into something actionable, something to look at. So it has about 120 built-in functions. So you have things like plot and bar. It's going to be a line plot, which you see right now. And then you also have bar charts as well. And that's just two examples of the plethora of options that you have within Matplotlib. So out of all the Python libraries that relate to visualization, Matplotlib is probably going to be one of the most robust ones you have. And I believe it could be very helpful if you had this library within your arsenal. Now, interconnectivity, once again, it does work with pandas and allows you to visualize data frames very easily as well. Now, I know this chart is probably not the prettiest, right? And we'll talk about other libraries that do pretty it up a little bit more, but let's just talk through this code real quick. So we're importing Matplotlib, and we're actually importing the PyPlot, so the plot line chart, as PLT. So we're just calling this PLT, and it's referencing not just the library, but also the type 2. And then we're calling our x-axis 123 and our y 246, and we're saying PLT, so the type is XY, and we have X here and Y here, right? So we're lining them up next to each other. We're now saying the title is going to be called a simple line chart, and then plot is show. So now just show it to me. And as we know, X and Y, so it's going to be 1 and 2, right? So X is going left to right and Y is going up and down. So you have 1 here and then 2. Next is 2 and 4. So we got 2 and then 4, and then same thing, 3 and 6. And you can see where that line starts and ends based upon the first and last point. Now the next ones we have coming up are going to be a little bit more pretty. So I'm excited to talk about those ones too. All right, so next up is Seaborn. This is like Matplotlib, but with more style, with more flavor to it. So some of the different functions it has is heat maps. You can see the bar chart that you're looking at right now. And then also a histogram plot, which shows you things over time, right? So the interconnectivity here is going to be Pandas and Numpy. So as we know so far, Pandas is going to help us kind of curate tables of data together. It's going to help us merge tables of data to help us create our source of truth. And then we can then take everything that was done with the Pandas adapter and now visualize it with Seaborn as well. So that's how the lineage and the connectors kind of come in together, right? You may just have one connector, you may have 2, you may have 5, you may have 10. It just depends on what you're exactly trying to do. All right, so let's just talk this code real quick and how we got this chart here. Now this is static data, right? So it's not anything dynamic in this one. And we'll talk about that later and how we can make everything dynamic. We're going to import Seaborn and just call it SNS. We're going to import pandas as well as PD because we're going to curate a table, a nested table, and then visualize the table data, right? So we're going to have the variable name called data, pandas data frame. So categories can be one side of this chart that we want. We're going to have different categories of A, B, and C. We're going to have values for the categories of 3, 7, and 5. And once again, right, A matches 3, B matches 7, C matches 5, because the X category, right? So we're looking at Seaborn here, bar plot, and it could be X category, Y values, and data is data. So that's where we're bringing the X axis over to category. The Y axis of values, 3, 7, and 5 is going to be the Y. And then data, to fill the chart up, is going to be everything that's in line 4. And now we just display that, and this is what we get. Now, none of this is probably going to make sense at all right now. I get it. You'll probably brain dump all this stuff because we'll go into each and every different type of function within every single language over time so that you can have hands-on practice with it as I'm doing it too. All right, so this is one of my favorite ones. It's called Plotly. It has about 60 different functions in it. So you can see a column chart right now, but they have bar charts, they have scatter plot charts as well. And then it's all web ready with hover and zoom, which is great because we know we want to have interactivity within the charts as well. It allows you to drill down on them too, just like Power BI does, but you can do this directly within code as well. So you have even more control of what you're doing. Now the benefit here is that it does compare to Power BI or Tableau, but unlike those applications, you can write the code here in the back end, visualize the data, test it, audit it, and then keep iterating upon it Whereas in Power BI and Tableau, you got to kind of clean your data, visualize it, and then go back to the back end, do whatever you got to do, and then go back to the front end again. We don't need to do that with Python. We can just do everything right here in the back end and then allow it to be available on the front end too. All right, so for this code, we're going to import Plotly as px. We're going to name our variable data. We're going to bring in for a category of fruit. We're going to call the fruit apple, banana, cherry. We're going to have another category called count, and we're going to have our count as 10, 15, and 7. And once again, they're going to line up with the 3 categories we have here. And our next variable is going to be fig. All right, so this is going to be px.bar, which is going to be the chart type. Then we have data. So we're bringing in this entire line of code here on the front end, unlike the other one is on the back end, right? And then we're going to say x equals fruit. So x is going to be these. The y is going to be count. So that's going to be the latter half. Then the title is going to be fruit count. So then we're going to say show it to me. So fig.show. So super simple, complex a little bit at first, but we'll get it all over time. All right, so Polars is basically Pandas on crack. So it has about 150 different functions in it. It's really used for high frequency trading, AWS data teams, government analytics, and it's really for data that has millions and millions of rows. You know, government isn't just 1 million employees, right? You have millions and millions of them. So you want something that's going to be flexible enough, that's lightning speed, that's faster than Pandas, that can optimize the efficiency of what you're trying to do so that you can deliver results faster. So think of it like Excel, but like 100 times better. And then some different functions that are here are going to be group by and select. But let's just walk through this code real quick. So first up, we're going to import Polars as PL. We're going to put a comment in here on what we're doing. So we're going to define our variable data. We're going to have 3 different sections here. One is going to be months. So we have January and February repeated twice. You have region, East and West repeated twice, and sales. And the reason we do that is because each month has a different region tied to it, so it makes sense. And then we have different sales amounts for each region tied to each month. And then we have a data frame variable, and we want to take Polars and we want to make it into a table of data now. And now we want to aggregate the total sales by month. So result is going to be our variable name, and we're going to say group it by the month. So we want to see just 2 different months and then aggregate it. And we can see the open parentheses here and it ends at the end, right? So everything's in one nested parentheses step right here. We're going to say sales. So we have our month column here. Our next column is going to be sales. We're going to sum everything by sales. We have 4 different ones, but since we're grouping it by month, that means one value is going to be 350 and one value is going to be 400. And then we're going to call it an alias. So instead of sales, we're going to say it's total sales now. And then we're going to convert to pandas for table display in notebooks. So the reason we did Polars here is because it's probably a lot of data, right? Let's just simulate and say we have millions and millions of rows and we don't want to use pandas for everything. We're going to use Polars now because we're optimizing our efficiency for government analytics. We're now going to switch to pandas because we want to display the data in a tabular format. And we're going to say print result to pandas. So it's calling this function on line 13 and printing to pandas. And just like that, we have a automated index row of 0 and then 1. So everything really starts at 0. And then the month is going to be February, January, and then total sales is going to be 400 and 350, just like we spoke about. All right, so Flask is really where everything comes in when we want to propagate something on a web application, work with HTML, and it allows you to have 50 different functions come in via the library, but you can then use Flask not just to talk to the web, to the front end. It'll work with HTML. It'll also work with PostgreSQL as well, so that you can then talk to a SQL database, so that now as data moves throughout the ecosystem, it's not just having data inputted into a web application, but also right back to the database, and so that it can store the data. But that's where Flask comes in, because Python can't just natively talk to a SQL database. That's where Flask comes in, because then it'll allow you that library connection to essentially create a harmonious marriage of them two. And this code is pretty simple because it's just saying, hey, return hello Flask whenever you log into the home page. Now we'll talk about Flask later down the road too as we create project. All right, so as I mentioned earlier, this is not an all-encompassing list of all the Python libraries, right? There's thousands of them. but this is a bracketed structure of what they fall into for Python. Now, once again, there's so much interconnectivity, right? You're not going to just use only one of them. Most often, you're going to use at least 3, maybe 4. You're probably going to bring in things like PySpark, which allows you to write natively SQL into Python as well. Or you're going to bring in other things as well so that you can visualize data. Or you may bring in something that's not even in this library set and you want to bring in your own custom thing. You always can do that too. But this visual allows you to see kind of how things maneuver through the ecosystem and to get to your final end result. But at the end of the day, Python isn't just about coding. It's about delivering actionable intelligence. It's about allowing the decision makers or whomever ingest your data to be able to look at it, understand it, interpret it, and know that the data that you're providing them is clean, is the source of truth, and that it's been validated. But once again, natively, Python only has about 70 plus different functions to it. But if you add all these libraries, you have a wide array of capabilities at your disposal, and then you can be able to deliver the results that you want to. And lastly, this is your orientation video. It's not your step-by-step. The next series of videos I have coming in are going to be going through all the different Python functions, how you use them, how you interpret them, what they mean. And I'm not just talking about a wave top explanation by any means. I'm talking about getting to the nitty gritty of every single line, every parentheses, every period, every operator, all of it, so you can understand fully at the beginner level. And then as we migrate over into projects and take everything that we learn and deploy projects as well. But in a nutshell, I teach Python in a plain language. There's no imitating jargon at all. I'm not like those folks out there that are data scientists or data engineers that just don't know how to talk English. I want to deliver to you results that help you deploy solutions within your workforce. With that said, hopefully this video is able to help you out. Let me know your thoughts down below, and thanks for watching.